So today we're going to prove the Schwarz inequality. This concept is very familiar to us in middle school. But back in middle school, we only used this inequality with real numbers. In this video, I am proving that it works with real vectors in the Euclidean n-space. Before going into the proof, I want us to have a look at the basic properties and definition of dot product. Please pause the video and recall before getting into the assignment. So now, let us prove the Schwarz inequality with two methods, starting with the first one by using properties of dot product. So, to prove this, for any real number t, we're going to have tu plus v multiply by tu plus v. It's going to be greater or equals to 0. And it's the positive definite property that we have mentioned. Expanding this, we're going to have t squared multiply by u multiply by u plus 2t multiplied by u multiply v, and the product of v and v. This is going to be t squared multiply the norm of u squared plus 2t multiply uv plus the norm of v squared. Now I'm going to let a equals to the norm of u squared, b equals to 2 multiply uv, and c equals to the norm of v squared. And now we're going to have with every real numbers t that this, it's going to be a t squared plus bt plus c. So this is very familiar. This is a quadratic polynomial that we studied in middle school. We're going to trace it back to this. So it states that at squared plus bt plus c, it's going to be greater or equals to 0. This means this quadratic polynomial cannot have two real roots. So this implies that the discriminant delta, it's equals to b squared minus 4 multiplied by ac. This is going to be less or equals than 0 because this doesn't have two real roots. We're going to have b squared is less or equals to 4ac. And now, we're going to substitute from here. We're going to have 4 uv squared is less or equal to 4 norm of u squared multiply norm of v squared. I'm going to divide both sides with 4. It's going to be uv squared is less or equals to the norm of u squared multiply the norm of v squared. Now, let's take the square root of both sides. We're going to have uv is less or equals than the norm of u multiply the norm of v. Now, we're done. Now, we're going to prove Schwarz inequality with the second method by using definition. This definition right here. What we're going to do is method 2. What we're going to do is we're going to see that u multiply v is equals to norm of u multiply norm of v multiply cosine of theta. So as we defined here, the angle theta between non-zero vectors u and v is defined by uv equals to the norm of u multiply the norm of v multiply cosine of theta. And now we have this. Let's recall a bit from the trigonometry circle. We have cosine of theta. Its absolute value is less or equals to 1. So what? So minus 1 is less or equals than cosine of theta. And cosine of theta is less or equal than 1. And we're going to plug it into here. Minus the norm of u multiply the norm of v is less or equals than the product of u and v. And the product of u and v is less or equals than norm of u multiplied by norm of v. And we're done.